Dancing involves strength, dedication, practice, and most importantly, physics. Dancers use physics in almost every aspect of dance, most of the time without even knowing it. In this project, we are going to explore how dancers, specifically ballerinas, use physics concepts as tools for protecting their bodies, maintaining their balance, maximizing their height in leaps, and much more.
When doing a leap, a dancer follows a simple parabolic curve, and as you can see, the path curves smoothly upward, reaches its highest point, and then curves back downward. A dancer uses other small steps before she does the large jump to gain kinetic energy. It is much harder to do a large jump from a smaller jump. As we know, thanks to Isaac Newton, a body in motion tends to stay in motion. Therefore, it is easier to jump after your body is already moving in that direction.
When standing flat on your feet, there is a greater area for the force of your weight to be applied. Because pressure equals the force exerted over area, a greater area means less pressure. When on point, a ballerina dances on the tips of her toes. The area over which the force of her weight is exerted is therefore much smaller. This decrease in area causes an increase in pressure. It would be ideal if a dancer could dance on the tips of all her toes, but we know from experience that most people's feet are not shaped this way. Most people have one toe that is longer than the others, which means they would have to dance on that single toe. For this reason, lamb's wool is used to make sure a dancer is dancing on the greatest area possible. Dancers put more padding under the shorter toes than the long toes to essentially raise the floor to each toe. This minimizes the amount of pressure by distributing the force of the dancer's weight amongst all 5 toes, rather than just the one touching the bottom of the shoe.
Let's take Rishika for example. Rishika's mass is approximately 45 kilograms. She weighs about 450 newtons. When standing flat, this force is exerted on 0.379 square meters of area. This results in 119 newtons per square meter of pressure. When standing on the balls of her feet, as dancers do when they are wearing soft shoes, Rishika's weight is exerted on 0.102 square meters of area, 1/3 the area of the entire sole of her foot. This makes the pressure on the balls of her feet 441 newtons per square meter. When on point, the area is decreased even more. Rishika has an Egyptian-type foot. With the lamb's wool, the force of her weight is exerted on 0.21 square meters. The pressure when on point with lamb's wool is 2,143 newtons per square meter, but without it, the force would be exerted on only her big toe. Rishika's big toe is 0.09 square meters in area. Therefore, the pressure on just her big toe without lamb's wool would be 5,000 newtons per square meter. Let's look at this chart. As you can see, the pressure is much greater when she does not have the lamb's wool. Why use lamb's wool instead of another material? Why not use wood or just shape the inside of the shoe like a dancer's foot? Why do dancers still put a little bit of wool under the big toe? Impulse is the answer to all of these questions. Impulse is change in momentum and is equal to mass times change in velocity, which equals force times change in time. Softer materials give a longer stopping time by absorbing the stopping force. By increasing the stopping time, the average force felt between the dancer's shoes is decreased. Here is a demonstration of the effect of lamb's wool on impact. As you can see, the time it takes for the object's velocity to reach 0 with nothing in between it and the ground is almost instantaneous. Now if we insert wool between the object and the ground, it increases the time that the object is being acted upon, and therefore the average force decreases. Wool is a perfect material for dancers to use because it is a very malleable material, meaning it is able to bend and change shape relatively easily. Going back to pressure, if a large enough force was put on such a small area of a dancer's foot, it could be very detrimental to their health. The lamb's wool works to make dancing safer for dancers by lowering impact. It is not uncommon for dancers to fracture toes because of the force being exerted on them.
Conservation of momentum states that an object of constant mass will spin faster when the radius is smaller. In simpler terms, this states that the smaller the circle you make with your arms while performing pirouettes, the faster and easier your pirouettes will be. We can see examples of this when watching a professional dancer do more than 30 pirouettes. Often they will bring their arms closer to their bodies and bring their leg lower to reduce their radius.
Ballerinas also use this concept when performing fouette turns. A dancer moves her free leg in and away from her body in order to keep spinning. There is a limit to the amount of time a dancer can pirouette because much of her kinetic energy is lost to the friction between her foot and the floor. With fouette turns, a dancer repeatedly moves her legs in and out, transferring her energy from potential to kinetic during each rotation. By utilizing the laws of conservation of energy and momentum, she is potentially able to turn for an infinite amount of time. Let's break down the fouette turn sequence. A ballerina begins her turn with a double pirouette in order to gain momentum and kinetic energy. When she reaches the front, the dancer will then plie and extend her leg away from her body and parallel to the floor. Because angular momentum is equal to the cross product of the radius and momentum, as the radius increases, her velocity will decrease. Mass, of course, remains constant. The ballerina then proceeds to pull her leg into her body, greatly decreasing the radius and causing her velocity to increase drastically. Notice also how she rises onto the ball of her foot. By decreasing the area of her foot in contact with the floor, much less of her kinetic energy will be lost to friction, allowing for her to perform a double or even triple pirouette in between her plies.
Dancers use physics in order to perform breathtaking steps on stage. Even though dance is a very creative and whimsical activity, all of it can be explained thanks to physics.